to solve Leetcode problem 2438, read product queries of powers. Let's first try to understand it. So we are given a positive integer n. So this positive integer gonna represent as an array. So basically, let me explain this area. If n equal to 15, basically we need to prepare a powers array. Yeah, because we are also having a zero index array called powers, but we are not giving it. Yeah, but we're gonna use this powers array to solve the problem. Yeah, so this powers array composed of the minimum number of powers of 2 that sum up to n. So the array is sorted in non-decreasing order, and there's only one way to form the array. So this means if we are giving a number n 15, there's only one way to form the power array. So it definitely is gonna be 1, 2, 4, and 7. So this is gonna be and this is 8. Yeah, so this is going to be the powers array, and sum up all of them are going to be 15, because this is the 3, 7, and 15. And what we're going to return? We're going to return the answer for all those queries, for each of the queries. So for example, from the queries 0 to 1, so this is index 0, this is 1, 2, and 3. So for query 0 to 1, this means we're gonna return the product of the two numbers, 1 times 2, so it's gonna be 2. So this is why the first number is gonna be 2. And 2, 2 for this number is gonna be 4. And let's check the last one, 0 to 3. So 0 to 3, it means definitely we need to calculate the product of all those numbers, 1 times 2 times 4 times 8, so it's gonna be 46. So this is why we return 46 for the last query. Yeah, so if we understand the problem like this, basically we can find a way to solve the problem. Yeah, so the difficult part may be how can we prepare this kind of a powers array. If we have it, definitely we can solve it by using prefix sum. Yeah, and the prefix sum here is just the prefix product, so we can use prepare a prefix product. For the first position, we're going to prepare a padding 1, and then it is 1, and it is 2, and 8, and 46. So for example, if we answer the last query 0 to 3, definitely it is 46 divided by 1, it is 46. Yeah, it is actually divided by this one. Yeah, the padding, this one, because we are calculating 0 to 3. So this is 0 to 3. Yeah, but in the prefix sum array, it is going to be the 1 to 4. Yeah, but this is okay. We just need to use 64 divided by 1. Now the problem comes, how can we calculate the powers array? How can we get it? So this is also easy, and if we are giving a number and we're going to turn it into a binary representation, because basically it's the same. Yeah, because the binary representation is just the powers of the each position, because for 15 it is 1, 1, 1, 1, and now we're going to just turn it into the binary representation. So the binary representation is 1, 1, 1, 1 for this number 15. So for the highest bit, it is 1. So this means 1 times 2 to the power of 3. So it is 8. And for this number, it's going to be 4. And for this number, it's going to be 2. And for the last number, actually, it is a low bit. It's going to be 1. Yeah. So first of all, we're going to turn this number into a binary representation. And then we're going to prepare this kind of powers array. And then we're going to use the prefix sum to solve the problem. Now it seems it becomes really clear about the problem. Yeah. So first of all, let's prepare a string. So I'm going to use a library from the Python. We're going to use a bin. Definitely this turn a number into a binary representation, and we want to take out the string. It's like 0x, because the binary representation have the 0x. We're going to take out this one, and we're going to just have the string like 1, 1, 1, 1. And in this way, and we can get the array. Now we want to get a powers array, so let me try to use a variable. Let me think about it. Maybe, yeah, I'm going to use a prefix array. So this is going to be the powers array. So I'm going to put it here, put it empty from the beginning, and then I'm going to check the character, each character inside of the binary string. So for IC, enumerate the binary string, but I want to reverse it first. Yeah, because for my calculation, this is going to be easier. So I want to check this character if it is equal to if it is not equal to 0, definitely I want to put it inside. But if it is equal to 0, it means, so for example, we just put 2 inside our powers array. We don't need to put 0. Yeah, we only put the valid positive numbers inside the powers array. So we have to check that. So if this is c equal to 1, definitely we have the number. So we want to put it inside our prefix array. So this is also the power array. So we want to put this number inside. So it's going to be 2 to the power of I, and it's going to be the integer c times this number. So if it is 1, 3, 1, we're going to turn it into a number 1 times 2 to the power of I. So for the first number, so for example, we have this kind of 3, 1, 1, 1, 1, 1, 1. And for the first one, we're going to check from the right to the left. So this is the low bit. So for the low bit, it's going to be 1 times 2 to the power of 0, it is 1. And for the second one, it's going to be 2. So we're going to put it inside the prefix array. So let's check what is inside the prefix array. It's going to be much more clear, yeah, to see what I'm doing. So the prefix array inside, as you can see, it is 1, 2, 4, 8. It is exactly what we need. Now we want to finish the product of the prefix array. So let me use maybe maybe I would to calculate the in place. So my prefix array is going to be equal to 1 plus the prefix. Yeah, so I'm gonna check from the second place. So from the 1 to the length of the prefix array, and the prefix I currently it's going to be times equal to prefix I minus 1. And now let's check what is inside the prefix array. Yeah, let's check if it is the product. So now it becomes 1, 1, 2, 8, 64. This is exactly what we need, because basically we need a prefix product array. So this is the prefix product, not prefix sum anymore. But we can use it to calculate the result. Now we're going to use it to get the final answer. So the answer is going to be the queries with A and B. So we're going to use the prefix B plus 1. As we prepare a padding, so we're going to use B plus 1. Minus, let me check. So what is the answer? So the answer, we're gonna return an array answer. It equals to each of the queries. So the answer I is the ith query. Yeah, since the answer is gonna be really big, we're gonna use a mod. So what is the answer? I forgot about what is the return. Yeah, so the answer is gonna be, so for example 0 to 1. I've already forget about it. So it is the first the product of the first two numbers. So this is why we're gonna use the prefix with b plus 1 and divided prefix a. So this is gonna be the answer. But as this one can be a really big number, so we want to use a mod. So we're going to use a modular mod, so for AB inside the queries. Now we need also to prepare a mod. It's going to be 10 to the power of 9 plus 7. So this is going to be the mod, this number. I think currently it should be okay. We're going to prepare a B plus 1 because we used a prefix with a padding of 1. This is okay. And for this A, definitely it's going to be A plus 1, but we use a prefix, so A plus 1 minus 1 is going to be prefix A, so it should be okay, I believe. So this is going to be the final result. Now let me just run it. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed all testing cases, and it's pretty fast. Now let's analyze the time complexity of this problem. Because n is 10 to the power of 9, this is okay, and the length of the query is 10 to the power of 5. Now, let's just check the for loop. So from here, we're going to enumerate the string s, because this string is just a binary representation. So if this n is 10 to the power of 9, basically this is just like 32 or 30. So this is a 30, we will ignore that. So from here, we're going to check the prefix array, but this prefix array is also like 30, right? Because from here it is just 30, and currently this is also 30. Yeah. So the time is just like 01. But here we answer all the queries. So for each of the query, it's going to be 10 to the power of 5. This means 10 to the power of 5 times this. Let me check. So this is 10 to the power of 5 plus 30. So this is going to be the final time complexity, because basically this is just 01. We modular mod for each inside, but here is 30. So the final time complexity going to be just the queries 10 to the power of 5. So this is going to be the final time complexity. Thank you for watching. See you next time.